Hello, Dr. Bill here. Today we're going to take a look at something called permutations, and you might not even know what those are, but they sometimes come up on the SAT and ACT. So we're going to look at these. These problems look scary, but they're easy to understand if you just know the basics. So we're going to take a couple of problems here. And the first thing is that permutations deal with arrangements. So for example, if a person buys 3 paintings and wants to know how many arrangements there are when putting them on the wall, that would deal with permutations. Combinations have order that really does not matter. For example, if you get a pizza with black olives, green peppers, and onions, that's the same as onions, black olives, and green peppers. The order just doesn't matter. So here, just remember, permutations are when order matters. Combinations are when order does not matter. And I think 2 keywords for permutation problems include arrange, rearrange, and actually arrangements, which are in these problems. So let's take a look at these. Again, if you find these 2 problems helpful, please do subscribe to the channel if you have not. Hit the like button, the bell icon to be notified of future videos, and kindly share with anyone who could benefit from the lessons. So let's take a look at this. We look at the first one. We also notice that these are not multiple choice problems. So these would be typical of what you might get on the SAT for a grid-in problem. So here we go. We have the first one, which says in the word victory, how many ways is it possible to rearrange the letters if none repeat and the letter T must go in the 3rd spot? Okay, well, in the word victory, we have 1, 2, 3, 4, 5, 6, 7 letters. So what we're going to do is draw 7 slots. 1, 2, 3, 4, 5, 6, 7. And it says that the letter T must go in the 3rd spot. So we're just going to write a T above the 3rd one. Okay, now here's the thing. If T must go in the 3rd slot, then we are locked into the letter T there. So that is just, there's one letter that can go in that, or one number, excuse me, that can go in that 3rd slot. Okay, so what does that mean for the rest of the slots? In the 1st slot, there are 6 possibilities. There are 6 other letters, so 6 letters could go in the 1st slot. But once we put a letter in that 1st slot, there are only 5 letters remaining for the 2nd slot. And again, once we put a letter in there, there would be 4 for the next slot, 3 for the one after that, 2 for the one after that, and then finally we have 1 letter left for the final slot. So to see the number of possible arrangements or permutations for this word victory, right, when T has to go in the 3rd slot, we would simply multiply these numbers. 6 times 5 times 1 times 4 times 3 times 2 times 1. So let's see what this gives us. 6 times 5 is 30, times 1 is 30. Times 4 is 120, times 3 is 360, times 2 is 720, times 1 is 720. So there are 720 possible permutations or arrangements for the letters in the word victory when the T has to go in the 3rd slot. So that's all there is to it. It's really not complicated. Okay, let's take a look at this next problem. This one's even easier. It says, Nellie Ebet makes 5 dresses for special occasions. The colors are red, orange, yellow, blue, and green. If Alanis wears 1 dress each day for 5 consecutive days, how many different color arrangements are possible? She can wear each color only once. Okay, now that last piece of information is very important because it's saying that, she cannot wear the same color dress on any 2 days. So that means that each day offers only one possibility. So again, we make 5 slots, 3, 4, 5. And as we said before, for day 1, there are 5 possibilities for the colors, and day 2, 4, then 3, then 2, then 1. We multiply all these to get the number of arrangements. So we have 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is 120. So there are 120 possible arrangements or permutations for the dresses if, again, none repeats and Alanis wears only one dress each day for 5 consecutive days. So there we have it. This is permutations. Again, they are not nearly as difficult as people think. If you found this explanation helpful, or these explanations, please subscribe to the channel, hit the like button, the bell icon to be notified of future videos, and kindly share with anyone who could benefit from these lessons. This is Dr. Bill. Thanks for tuning in, and we will see you on the next video.